UltraVision II and our new Phoenix chipset make an all-new system architecture for the 7000 series oscilloscope that provides advances in a number of important characteristics for the scope. The ASIC chipset improves the waveform capture performance and the frequency accuracy, while the UltraVision platform adds color grading and other capabilities to the sampling and plotting. Together, the 7000 provides faster, more accurate, and more vibrant visualizations of your embedded signals. Now let's take a look at waveform capture rate. So here on the 7000, we can turn on our channel at 10 gigasamples per second. And now let's look at the waveform capture rate. So we're going to turn on the counter, and that's showing your waveform capture rate at about 680,000 samples per second. Now the great thing about the 7000 is how many other things we can turn on and still really accomplish a super high sample rate. So turn on a couple different things here. Now turn on the FFT. We've got the color grade on. Let's turn on a cursor on that FFT as well. So we can see the peak cursor at the 25 megahertz of that sine wave. Now let's see what else we can turn on as we continue to work on this. Let's turn on some measurements, like our digital voltmeter. Can turn that on as well. Now we can go ahead and let's add some serial decode capabilities. So we just do serial decode on that underlying sine wave there in a little parallel bus mode. And now let's look at search and mark capabilities. So looking for peaks and edges within our single memory sweep. We can create reference waveforms. We can also add a table of measurements as well. Now we can see really a whole set of measurements being done on a number of samples and really still maintaining that 680,000 waveforms per second area. Another important improvement made possible by the custom chipset is improved frequency accuracy. Let's take a look at how frequency accuracy makes signal analysis easier using this 11 megahertz signal. I'm going to go ahead and turn the persistence on to infinite so we can see the jitter of that signal. And now we're going to move the trigger delay out to 1 second. So we're looking at the results of that 1 second after the trigger. So any really jitter in the sampling is going to show up here. And we can see here that there's about plus or minus 1 nanosecond or so of jitter a second later. So that's really down to single-digit parts per billion jitter on the sampling technology itself. So really a great way to look at the super accuracy of the frequency measurements you can make, as well as all your signal technologies. One of the advantages of having a high sample rate scope that's also very accurate in time. One of the advantages of UltraVision II is it allows us to provide an advanced color grading capability. So now we can see, when we turn signals on, we can see in addition to the usual sort of persistence, we can see additional information about where signals interact, how long they appear in a particular area on the screen. So when we get to really complicated signals, you can see a lot more detail in timing, interaction between signals than just you would on a normal oscilloscope. And that's one of the advantages, is the plotting capability of the color gradient, which can be used on any of the channels and on the FFT as well. So these capabilities, in addition to the front-end frequency and waveform capture capabilities provided by the ASIC, make the overall platform and architecture really a great step forward, providing a lot of capability for your oscilloscope and your embedded design needs.